Hello, welcome back. In this video, we will focus on the second type of van der Waals force, which is permanent dipole or also known as dipole-dipole forces. So for your information, dipole-dipole forces always present between polar molecules. Okay, why this happen? Because at the polar molecule, there will be always one part is partially positive and another part is partially negative, like HCl. There is no moment that the hydrogen will become partially negative. Hydrogen must be always partially positive, while chlorine must be always partially negative. The charge between hydrogen and chlorine will never change. So that's why we call this one as permanent dipole. Again, intermolecular forces exist between molecules. So here has one HCl molecule, here has one hydrochloric acid molecule, and then here also have another HCl. So this one also considered as permanent dipole. Okay, so we very quickly, no matter what are the compound, as long as for the polar molecule, there must be one side is partially positive, another side is partially negative. So negative will attract partially positive, while partially negative again will attract partially positive. And then when you look at the bottom second row, the partially positive will always attract the partially negative side, and this partially negative side will attract partially positive. So this condition, the partially positive and partially negative side will not be changing. So that's why we know it as permanent dipole. Okay, so after you know the meaning for the dipole-dipole forces and also London forces, let's look at what's the difference between these two types of van der Waals force. So dipole-dipole forces also will known as permanent dipole, while London forces also can known as dispersion force. So second difference is dipole-dipole exists between polar molecules, while London forces exist in all the atoms and molecules. Okay, no matter they are polar or non-polar molecules. So this is a diagram where show the dipole-dipole forces in the green line here. And this is the diagram to showing London forces is temporary dipole. Okay, so now we want to look at what are the type of intermolecular force that are exist between the molecule. So if we want to know what are the intermolecular force, again, first step, we have to identify type of compound. As we discussed in first video, so HBr, SO2 and CH4, all these are covalent compound. So after we know they are covalent compound, then the second step we are going to look at polarity of the molecule. Okay, so HBr is polar molecule. So just now we already have the idea, if polar molecule, both dipole-dipole and also dispersion forces are present between the molecule. Okay, because HBr, hydrogen, always partially positive, while Br always partially negative. Dispersion force is appear in all the molecules, no matter polar or non-polar. SO2, so before you can determine the type of before you can determine the polarity of the molecule, means that you have to draw the Lewis structure. So Lewis structure for SO2, sulfur 6 valence electron, oxygen also 6 valence electron. Total out is 18. So yes, so and then here we have 2 terminal atom. So means 8 times 2, 16. So you have 1 lone pair. So molecule with the lone pair electron, we know that it is polar molecule. So as long as it is polar molecule, so dipole-dipole forces and dispersion force are present between the molecules. The last example here is CH4. So if we draw the Lewis structure for the CH4, we already know it will exist in tetrahedral. So tetrahedral is the basic shape and then without lone pair electron. So CH4 is a nonpolar molecule. Since it is only a nonpolar molecule, so only dispersion force or London forces are present between the molecule. Okay, we already discussed two types of van der Waals force, dipole-dipole forces and London force. So now let's do a very quick summary. The strength of the van der Waals force depends on the polarity of molecule. So generally, polar molecule will have stronger van der Waals force compared to non-polar molecule. The second factor that we will consider then will be the molecular size. The larger the molecular size, the stronger the van der Waals force. And then molecular shape, we didn't use bigger or lower or stronger, but we will use the term linear shape. So if the shape is linear, so the strength of the van der Waals force also will be stronger. And then the second point, based on here, generally we also will have the idea that dipole-dipole forces is stronger than London forces because dipole-dipole forces is permanent while the London forces is temporary. Okay, so in next video we will going to discuss about hydrogen bond.